By the way, let's start with a little chat here. I guess that all of you are Java developers, right? Who is not a Java developer? Not? So I guess that you are a sysadmin? Okay. That feels, okay, that supports a JVM application, Java application on your environment, and that's why you are here, right? For those who are Java developer, have you ever asked, because one of the greatest features of the JVM is to be portable, right? You get the bytecode and place it on different Java virtual machines, no matter if it's hosted on mainframe or a desktop, or different kind of CPUs. The application will run the same way, right? And have you ever asked why you are taking a Java application and placing it inside a Docker container? It seems like a little bit odd, isn't that true? But in fact is that containers are changing the way that we deliver software. So people started to place Java applications inside containers because it's easy, and then we'll talk more about that during this session. My name is Rafael Benavides. I'm a Brazilian, and I talked a lot yesterday. That's why my voice is like Donald Duck. Essentially, I'm a Java developer, okay? But I work in the DevX team of Red Hat, which means that I go to conference to talk to people like you and understand what are the situations that you have on your company, on your application, understand those pains, and bring that to Red Hat to improve our product, and then get the improvements that Red Hat made on their projects and their products, and bring that to you. And one of those things were this research about Java application inside Docker. Well, I told you that containers changed the world, right? Not only the IT industry, but even before that, we used containers to deliver things worldwide. And sometimes things goes wrong. I made this question to you, and something really happens when you place a Java application inside the container. When you place just like that in a no restricted environment, on a no restricted container, that's fine. But we will see that when you restrict the memory or the CPU in the container, things can go wrong. And you might ask, why things can go wrong? Why do I want to restrict a container? Imagine that you have a huge server with 8 gigs of RAM, 16 gigs of RAM, and you don't want to have many containers competing among them for resources. So you can restrict a container in terms of CPU and memory and say, okay, this container here can allocate just 100 megs. And this other container can allocate just half gig of RAM. I have 16 CPUs, but this container you will use just 1 or 2 CPUs. So sometimes we need to restrict our containers. And this section that I'm doing now, that I'm presenting to you, is based on this blog post here, which became very famous. I posted this 1 year ago, and since then the research continued, and I've made some updates here March of this year, then for JDK 9, and then with the release of JDK 10, I have updated it again. So we'll do a research and understand what happens. For both of them. It affects both OpenJDK and Oracle JDK. okay? Well, so we are all placing Java application inside containers. That's cool, that's nice, even because it makes our lives as developer or as sysadmins easier. For example, in the beginning, we all want to deploy our Java application, right? So we need a server with an operational system, a Java virtual machine with a specific version, Java 6, Java 7, or Java 8, it depends, Java 10. By the way, just as a matter of curiosity, how many of you are running Java 10 on production? Java 9? Great. Java 8? Woo, so this talk is to you. And then we deploy our application server and our custom configurations. And before containers, we just had the WAR file or jar file or the enterprise archive EAR file. And what we did in the past was we sent an email, the developer sent an email to the sysadmin people and saying, okay, I want to deploy my app. Here is my app attached or coming from a CI/CD server. And I want to deploy this application here on production. But on production, it's totally different from your development environment. You used to have JDK 8 with Wildfire 9, and then on production you have the JRE 17 with WebSphere, Oracle, and you just request to create a data source and with a specific JDBC library. With Docker, those things are gone. You can provide a Dockerfile or a Docker image with everything inside. Your app server, your custom configuration, your dependencies, and even your WAR file. Environment variables, everything placed, and then you just send it to sysadmin people and just ask them to run that image, which is nice. So containers changed not only how we ship things worldwide, but also changed the way that we deploy software inside our company, or even outside of our company. And usually this is a container, and when we decide to have a cluster of containers, this is like we have with in-house solutions. Okay, but behind the scenes, what happens to a container? Well, Docker containers and Linux containers in general, they use a specific kernel feature that uses C groups and namespace to create it restricts the CPU, the memory, and other things like processes, mount points, host names, in a way that you think that you are just like a virtual machine. But in fact, it's not a real virtual machine. It's just a feature of the kernel that restricts the process, and that process feel that it has that specific files and libraries and resources. One of those things is controlled by C groups. And C groups, you can specify the memory limit. But some applications existed before containers. Containers, they are not a new technology. Of course, it became very popular the last 2 or 3 years, maybe 4 years since 2014. But the history of containers started in the year 2000, where many things evolved. One of them was the creation of C groups and namespaces as part of the Linux kernel. Then it had the Linux Container Project, LXC. And then the company Docker started in 2013, more or less at the same time where the Red Hat Enterprise Linux 7 was released. And since then, the ecosystem has evolved. But some application exists before the dawn of containers. Like, for example, Java. Java started, the first Java version was released in 1996. Java EE 1.2 was released in 1999. So most things are not prepared to run in a container. Let me give you an example of other applications or other commands that was born before containers. I have here a Docker machine created with 1 gig of RAM. Okay, you can see it here. That my advanced, let me see where I can see memory. System, yes, memory. It's just 1 gig of RAM, okay? I created that using Docker machine. So if I do a Docker machine ls, I can see that I have, by the way, I need to regenerate this certificate for the Docker machine with 8 gigs. Docker machine regenerates. Okay. Docker machine ls. Okay, my environment at this moment is pointing to this 1 gig of RAM machine. If I do a Docker machine SSH, Docker 1024, and I do a free.h, I can see almost 1 gig of RAM and almost 1 gig of RAM of swap. But let's start running a container here. Let me do a Docker run. Let me just copy what I have here. Docker run. I will assign a terminal. I will remove this container after the execution. But now I'm also using this flag here, -m. -m limits the memory of this container. Okay? And I'm limiting also the swap memory. But I will use the CentOS image, and I will run the same command that I did on the terminal, free-8. I restricted the memory, and it's still saying that I have 1 gig of memory available. And that's not a bug on CentOS. I can get another distribution here, like Ubuntu, and run the same command, and I will have the same result. Because this application, free, was created before containers. It doesn't understand that's run on a container. So how does it impact the Java application? Let's run a Wildfly swarm, a Wildfly server application. I'm using an interactive terminal here. And I will give a name, my Wildfly, but I will really restrict the memory to 50 megs of RAM. The name of the image, JBoss Wildfly. Oh, I have already that name. Docker RM and Docker, oh, not now. RM, Docker PS means AQ. Okay, and in parallel, I have started here a Docker stats. You can see that the CPU usage is really high. I can see the limit of 50 megs. And the CPU usage is really high because the JVM is trying to allocate memory, and there's not enough memory available. And then there are a lot of cycles of garbage collector trying to allocate. But since it does not happen, you can see here that it received a kill sign. So when you specify a memory limit in Docker, It means that you are telling to this process, if it requires more than 50 megs, just send a Q sign. That's what Docker does. It not really creates a small environment that you can see the limit of the memory. Let's inspect that container. By the way, let me run it again. Docker am my wildfly. So you can see here that even it was even started with a max of a heap of half gig. Okay. Again, high usage of CPU. Memory is limited. And then the process will die eventually. By the way, this command that I'm running here is docker stats. Okay, high usage. Come on, come on. Yeah, it died. So now what we will do is inspect this container and see what happened to it. Docker inspect my wildfly. And here, one of the first things that we can see is the state. The state of this process is exited. Okay, we know that. It's not running, it's not paused, it's not restarting. But something interesting here is that it was OOM killed, out of memory killed, which means that the process was killed because it tried to allocate more than 50 megs of RAM. Okay, now let's do a little play here. I have built a Spring Boot application that it's very simple. It will try to allocate memory, creating its strings in a loop until the used memory reaches the max memory. And the API that I use here is runtime, get runtime, and then I look for the max memory and my total memory. And something that you can notice, and here, oops, is that when you use those API, runtime, get runtime, max memory, total memory, and available processors, I did a little research and saw that this specific call is used in different application servers. For example, in Tomcat, it is used on different points. In Wildfly, it's also used on different on this processor info. In Vertex, is also used. So it's a very common and very used API. So let's run that application. And my application here, let me show you the Dockerfile for that. I'm using OpenJDK9 because I wanted to reproduce the issue using the JDK9, and I used the flag print flags final so I can look what kind of information the JVM was set. Okay, so let me run this application here. So I'll use Docker run, interactive terminal. I will just delete this container after the execution, and I will give the name my container 150 because I restricted the memory just to 150 megs. Okay? And we can see here that the application is starting with 150 megs of memory. Of course, there are a lot of CPU usage because until it starts, it will have a lot of garbage collector activity. And then I will, this application here, as I told you, there's an endpoint called memory that will allocate the memory. So let's try to access that using curl. Curl Docker machine IP and the endpoint that I prepared. So you can see here that's starting to allocate memory, and it worked. Allocated more than 8% of memory. Almost 220 megs of the max allowed memory of 241. Here we can have at least two questions. First, I told to Docker to restrict my JVM to 150, and it told me that it was able to allocate almost 220 megs. So why is that? Why I told to restrict to 150 and it allocated to 220? Is it a bug on Docker? No. Let me explain what happens in this case. Docker, when you tell to use memory, it also allocates the same number as a swap. So 150 megs was placed on RAM and plus 150 megs on swap. So part of this memory, the JVM used and allocated inside the swap. Okay, so that's the first answer. And we can even play with that. For example, Docker run -m 100 megs, and what's the other? Memory swap and bytes. Memory swap. If I decide to use, for example, less memory, for example, less swap than the memory, like for example 90 megs of JBoss Wildfly, it will complain. The minimum memory swap limit should be larger than the memory limit. See usage. So the Docker documentation has all the combinations that happens when you specify memory and memory swap. But by default, if you don't specify, it will create the same amount of memory for both. So in this specific container here, even if I run Docker stats, that says that my limit is 150 megs, I have plus 150 megs of swap. Okay, now what is the second question? The second question is obvious. Why it decided to allow almost 250 megs of RAM? That's very important for the whole context of this talk. When we didn't specify in our Dockerfile any parameter here, right? So we told to the JVM, please use your own ergonomics to decide what's the better values for the heap. And when we look at the ergonomics page, we'll see here that the maximum heap size is the smaller of one quarter of the physical memory, or 1 gig. In our case, this environment has 1 gig of memory. So 1/4 is almost 250. And it's almost 250 because the memory is not only about the heap. The JVM memory has to allocate space for native JR, the perm region, GNI and IO threads. So now we have the answer for this question. But something can go even wrong when you decide put more memory on your application. And that is very common when, for example, you are moving your application from your laptop to a server. So let's see what happens if I run the same application on a server that has more memory. So in this case here, I also have a host prepared with 8 gigs of RAM. Okay, so let's point our Docker environment to there. Let's kill this process. Let's point our Docker to 800 and 192. Same here. Docker stats, perfect. Let's run the same command, the same application, but let's give more memory. Let's give, for example, oops. Let's give 600 megs of RAM. Okay, it's the same application. I just gave much more memory. I gave 8 gig. I gave from 150 to 600 megs, and I'm running that on a server that instead of having 1 gig, it has 8 gigs of RAM. Remember, my application was able to respond. Now I will invoke the same endpoint on the 8 gigs host, and we will see it's trying to allocate. The limit is 600, and it got killed. So this is a big problem. I gave more memory, and the process got killed. This is what can happen when you are running your application in a restricted environment and with a lot of memory. So some sysadmins can think, oh, it's that Java application again that's eating all the memory of my servers. But we need to understand why. What happened here? So let's do a research, a study of this case. If the JVM is running on an 8 gigs machine, how much is 1/4? 2. So the JVM thinks that it can allocate 2 gigs of RAM. Let's inspect that. Grab. Place it here less. No. Max heap size, 2 gigs. My application thinks that can allocate 2 gigs. So more than 8% of 2 gigs, the application will try to allocate, but my container is restricted to 600. That's why it got killed. It tried to allocate more than it was allowed. So the solution here is very simple. We cannot trust the JVM to decide about the ergonomics, at least the JVM 8 and 9, to trust on it and decide to adjust the max heap size. So one solution that I implemented, the first solution, was to modify my Dockerfile and place an environment variable called Java options. That way, I can restrict my container, but I can say to the JVM, use this specific memory, this specific parameter for the memory. For example, I can run the same application here using the environment variable and of course it's another image that I've created. I specified the MX as 300 megs. That way, my heap is locked to 300 megs, although the limit of the container is 600. So now we can invoke our endpoint. Oops. And we have here, it located more than 8% of the max allowed JVM memory, which is 300. I locked. I don't trust, and I didn't trust on the JVM to set the parameters to me. But we can make it even better. There's a project. I don't know how many of you have heard about Fabricate. Fabricate is a community that provides solutions for Java applications on containers. And one of the things that they provide is a custom, it's a custom-based image that's called Java JBoss OpenJDK 8 for those who are running Java 8. And one of the things of this image, if we look at the source here, the source of this image, is that it loads the core limit and the max memory from the C groups, and based on the max memory, it will create the options to you, the main dash XMX and other important parameters that you might need based on the limits of the container. So let's run here a container with no limit using the Fabricate version of this application. You can see here that's really easy to use. I just need to declare it. Since it's ready to run jar applications, you just need to inform on the environment variable the name of your jar file, and that's it. You don't even need to specify a CMD with the java-jar and the parameters. Okay, so when you run this application using the Fabricate, oops, Docker rm my container, you can see here that it created for you a Java with a lot of parameters, but nothing regarding memory. If I take the same image and decide to restrict that to 150 megs, it will automatically add to me the dash XMX of 38 megs. That was made automatically, based on the limit of the container. If I decide to run 1 gig of RAM, it automatically created dash XMX half gig of RAM, half gig of heap. You can see here in the documentation that by default it uses, let me see here, the memory ratio is 50% of the memory, but you can overwrite that ratio using this environment var. Okay. I told you that this happened on JDK 8 and on JDK 9, but since JDK 8, they introduced a new patch that's here on the slides, and this patch was an experimental feature. So if I run, if I get OpenJDK with the API update 1:1 and show the settings of the VM on a container restricted with 1 gig of RAM, it will estimate my heap size of close to 2 gigs, because that's the default, 1/4. But on the JDK 1.3.1, I can use these flags here, unlock experimental VM options, and use cgroup memory limit for the heap, that will give me 50 megs of max heap size, because this experimental feature read the values from cgroup. Okay, so let me now use my my other version of the application who uses cgroup. I'm using here OpenJDK9 with those flags enabled, unlock experimental feed. Wow, I hope it's not an earthquake. Unlock experimental VM options and use cgroup memory limit for heap. It's the same application with the same container limit of 600. Docker and my container 8 gigs JDK9. Docker logs. Okay, it's limited. Grab max heap. Max heap of almost 150 megs. So let's invoke our application. Let's invoke our application. Yeah, 150 megs, just by enabling those flags. Okay, but the good news is that on JDK 10, those features are not experimental anymore. So I have here another version, another image of the same application that uses OpenJDK 10. So what I did was just update to OpenJDK 10. You can see here that I don't have any flags enabled. And let's try this application this time using JDK 10. Docker rm. Oops. Driver fail. Oh. JDK 10. And now we can invoke the application. And it gave me the same result just by trusting on the JVM ergonomics. I even could try the JD. By the way, if you try to use those flags, unlock experimental features, use group memory limit for heap on a JDK 10, just like I'm doing here, it will say, okay, I understand, but there's a warning. This use group memory limit for heap was deprecated in the version 10 and will likely be removed in a future release. So that's just a temporary solution for the JDK 9 and JDK 8 with the update more than 131. Well, that covers everything that you must know about Java. And I'm open to questions. Is that something that you have already faced? In this case, I will do the question. Have you ever faced such problem on production? Yes. Yes, right. And were you aware of those solutions?
I read your blog on your...
Oh, great. The other, they keep using the default values because they are really tiny. The perm size, I think it's the default. It's just six. It was used to be 54 megs. The threads are they are just too tiny to concern. Yeah. So. Yeah, so you saw that the Java 10 solved all the problems, but people here, besides, I guess that it was two of you, are running Java 9. All of the rest of people are running Java 8. So for Java 8, we have two solutions. The one is to use Fabricate, that before having the experimental feature flag, the Fabricate image could read the information from C groups, or use the OpenJDK or Oracle JVM after the update 131 and enable those experimental features, and that will allow to read the information of C groups and work. Of course, Java 10 and 11, that problem is solved. Well, it has that name because it's experimental, but it works. Of course, on Java 10, I'm not really aware of the lifetime, the support of JDK 9. I think I heard that it was moved to Oracle and OpenJDK have support now just to JDK 10. I might be wrong, but it's right. They are pushing to JDK 10. So if you are running JDK 8, they are strongly encouraging you to update to JDK 10 and skip, not skip, but if you can go to 10, just go to 10 and you will be supported. Yeah, they have now a shorter release cycle. So it's like one JVM each 6 months. So things are going pretty fast, at least related to the JDK and JVM features. Yeah, there is. So the question is there any other concern besides the memory? Because I just presented issues related to the memory. With CPU, you can have, how can you say, a contention for threads when you, for example, you specify, I want to have container that uses just one CPU. But the JVM will detect that you have 16 CPUs, and that can cause certain contentions. But that's really hard to demonstrate. But it's also part of the same solution, because Fabricate also consider the number of CPUs to adjust the number of garbage collector threads.